So we're going to do a couple of each question. So with number 1, super easy. Anytime you're breaking down a square root, you figure out what multiplies to make 18. So 2 times 9 is 18. 3 times 3 makes 9. We circle the pair, and we box the loner. The pair goes on the outside of the doghouse, and the loner is stuck underneath. So you'll do the same thing with numbers 2 through 5. So you break down your numbers. This is 3 times 9. This is 3 times 3. Pair, loner. We had a pair of 3s. Comes out, the loner stays in. Very easy. So if we skip down to number 9, in number 9 we have to do the same thing. In order to add these, we need to break it down first. 8 is the same as 2 times 4. 4 is the same as 2 times 2. We circle the pair, we box the loner. So 8 is the same as 2 root 2. Off to the other side, we break down the square root of 32. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4. 4 is 2 times 2. Pair, pair, loner. So 2 gets to come out. Another 2 gets to come out. 2 times 2 is 4. Loner is a root 2. So now we can add these. We broke them down so that now we can add them. 2 root 2 plus 4 root 2 leaves us with 6 root 2. So then you'll do the same thing with number 10. Number 11, when you multiply, anything inside can multiply with anything inside. 2 times 5 is 10, so it stays inside. Same thing with number 12, inside times inside is the number 24, but you can break that down. 2 times 12, 2 times 6, 2 times 3. So the insides multiply together. So the outside is just a 2. The insides multiply together to make 30. 14 distributes. The insides multiply. Root 6 minus 5, root 2. Those don't go together because they're not both underneath a square root sign. So now if we go back to number 6, we have to do something called rationalizing the denominator. Whatever is on the bottom goes on the top and the bottom. So the top becomes 3 root 2. The square root of 2 times the square root of 2 is the square root of 4, which simplifies. Square root of 4 is just the number 2. Number 7, same thing. Root 3 on the top times root 3 on the bottom. Simplify. And number 8 as well. Very easy. Okay, so let's go ahead and look at the next piece. So in these ones here, I'm going to do the bottom first because they're easier to see. Okay, 17. So this is a 45, 45, 90 triangle. This one has a 16 that's across from the 90. So in order to solve this, I need to make an equation. X root 2 equals 16. I get x by itself by dividing by root 2. That's the answer, but in math, we can't have a square root on the bottom. So we multiply it times the top and the bottom. That becomes 16 root 2 over root 4. The square root of 4 is just the number 2. This is a number, that's a number. 16 divided by 2 is 8. So your final answer is x equals 8 square root of 2. So that's what x is. Same exact idea with number 18. Number 18, we have this 6. It's across from the 60. So I put the number 6 across from the 60. I turn this into an equation. I get x by itself. I rationalize the denominator. I can simplify. So my answer is x equals 2 times the square root of 3. So that means that 2 times the x value, if this is x, 2 times x would be 4 root 3. I just double the front number. So the side across from the 30 is a 2 root 3. The side across from the 90 is a 4 root 3. Let's look at number 15. In number 15, I'm going to start with this triangle on the left, 30, 60, 90. The side across from the 30 is an 8, which means the side across from the 60 is 8 root 3. Side across from the 90 is 16. So now I can solve for x because I have two sides of a right triangle. Pythagorean theorem says 16 squared plus 12 squared equals x squared. Sixteen times 16 is 256 plus 144 is x squared. Take the square root of both sides. X is 20. Same idea with number 16. On number 16, I fill in what I know. If the whole thing is 13, and this piece is 3, then that means that this right here is 10. 10 plus 3 makes 13. If this side is 4, then this side here is also 4. So I can use Pythagorean theorem to solve for x. 3 squared plus 4 squared equals x squared. I would get the number 5. Square root of 25 is 5. Then I'll do the same thing here. Pythagorean theorem. 4 squared plus 10 squared equals y squared. So the answer is the square root of 116, which you could have also written as a decimal. So if there are no angles, then we have to use Pythagorean theorem. If there is an angle, then we use a special right triangle. Next, determine if the numbers represent the lengths of a triangle. So what you need to do is you need to add the smallest and subtract the biggest. That's called the triangle inequality. 8 plus 7 is 15. 15 minus 7 is 8. These numbers would have to be between, all of these numbers have to be between 8 and 15. Here, just kidding, this is a 7. So all of those numbers have to be between, is it 7? 15 minus 8 is 7, yeah. All of those numbers are not in between. It equals 7 and it equals 15. That's not good. So this is not a triangle. Let's try 21. Add the smallest, 6, that's not the smallest. 6 plus 8 is 14. subtract the biggest. 10 minus 8 is 2. All of these numbers are between these two values, so we're good. So it is a triangle. So now what we have to do is c squared, a squared plus b squared. The biggest number is 10 squared, which is 100. A squared plus b squared. If they are equal, that means that this was a right triangle. So let's try that again with 23. 23 is a triangle. That's going to be 11 squared box 10 squared plus 7 squared. So in this one here, this is smaller than that. So this here is acute. Because this number is smaller than that number. Very easy. 28 goes back to special right triangles. If these are the same, it means they're both 45. The side across from the 45 is 5 root 2. So x is 5 root 2. And then the equation wants me to put another root 2 behind x. Root 2 times root 2 is root 4. Root 4 is 2. 5 times 2 is 10. So try the same thing with this one here. 30, we don't need this other side of the box. This is called a special right triangle. No, it's not. It's called Pythagorean theorem. 8 squared plus 8 squared is d squared. Solve for d. You're good at that. 29 is a 30, 60, 90. Not too bad. Let's look at one more page. Number 11, same thing. We can cross out half of our, 31, sorry. Cross out half of your triangle. No angle measures, so that means it's Pythagorean theorem. 32 is a 30, 60, 90, so complete that hashtag. 33 says what type of special right triangle? If it has a square root of 2 in it, that means it had to be a 45, 45, 90. That is your answer there. 34, if it's equilateral like this, if you see the word equilateral, then that's 60 and that's 30. Now you can set up your special right triangle and solve for x. "35 through the bottom are all super easy. It's all Pythagorean theorem. An 80-meter tower is secured with a wire that extends from the top of the ground, from the top of the tower to the ground 40 feet from the base. How long is the wire? 80 squared plus 40 squared equals x squared. 36. A wire extends from 2 feet below the top of the tree of the stake. What is the tallest tree that can be braced if it's a 25-foot wire? There's the wire. And it's staked 15 feet from the ground. Again, Pythagorean theorem. X squared plus 15 squared equals 25 squared. 37, Keegan traveled west. West would be left and right. Cameron traveled north. North would be up and down, leaving us with an x. 40 squared plus 50 squared equals x squared. So all of these word problems are always Pythagorean theorem. Not too bad.